Okay, Ms. Mikhail. So we're inside of a stroma and a thylakoid, and we have a water molecule which is about to undertake photolysis, where it's going to be oxidized. It's going to lose its hydrogen atoms, okay? And these hydrogen atoms are going to pass their electrons to photosystem 2, right here. And they're going to go to the activation center at photosystem 2. Now, photons are going to be absorbed by chlorophyll pigment in photosystem 2, and that is going to provide light energy to the activation center, which is going to charge and excite these electrons. The excited electrons are then going to have the energy to begin traveling down the electron transport chain, jumping from protein to protein. As they hit the proteins, they open up the channels and allow hydrogen atoms to flow in to the thylakoid. The electrons continue to jump until they reach photosystem 1. At this point, they're out of energy, they're exhausted. So, new photons will be absorbed by the chlorophyll pigments in photosystem 1. That will provide light energy to the activation center in photosystem 1 to recharge the electrons so they can go the last couple of proteins, and when they get to this point, NADP is here to accept the electrons, and we have NADPH. And that would happen to both of them. Alright? So we've got our NADPH after that. That's the product of photosystem 1 is NADPH. Now you're probably wondering what was the product of photosystem 2. Well, we're not quite there yet. We have a higher concentration gradient of hydrogen inside the inside the thylakoid now than outside, thanks to the electrons opening all these channels. And so what's going to happen is the hydrogen are naturally going to follow the concentration gradient out of the thylakoid through the ATP synthase, okay? So as the hydrogen are flowing out, that's providing energy, enough energy that ADP, a phosphorus molecule, can come together and create ATP. So the product of photosystem 2 is ATP, product of photosystem 1 is NADPH.